You try, meanwhile I'll adjust the diagram. Okay, I brought the diagram. What will be your approach? First, try to think on approach. What method has to be applied here? This is R. This height of the step is R, no? So here is the center. I think the center of mass here will the position will be same there only. This is a point P1, I'll write it. This is P. This is P. I think I'm helping you so much with the diagram. At least now, pure rolling. It's having a pure rolling, and the corner of step is sufficiently rough to prevent any slipping of the disc against itself. It's saying there won't be any slipping occurs at the point P1, and it will successfully roll. V naught omega naught. So the moment it comes and strikes here, no, so there'll be an impulse, then impulse will be there. So that impulse, how it will act? It will act in this direction. This impulse, what it will do now? A component of impulse, resolve this. If you resolve this impulse, yeah. The component of impulse, it will decrease the velocity, linear velocity. A component of impulse, this impulse will decrease linear velocity. And this impulse, what is acting? It is acting passing through center mass. So anything will happen to omega naught. Omega naught will not change. Am I right? Everyone will accept. I'm trying to confuse you here. Very badly, I want to confuse you here. So what I say, this J cos theta, or say some theta anything, whatever you want to write it. So let it be theta. Let's take. Now this J cos theta, what it will do? It will decrease velocity V naught. Okay, V will be less than V naught. Okay, fine. Who will decrease angular velocity? Is telling sufficiently rough to prevent any slipping, no slipping occurs, then somebody should decrease omega naught also as a same impulse, but that impulse will pass through center of mass. What is the angular impulse set up by J will be zero, no? Then it will have here what? Backward slipping, but what is saying it will here have pure rolling. If you can understand, please get the question first properly, then you'll be in better position. So pure rolling. Now also pure rolling. The next question comes, who will decrease angular velocity? The impulsive friction. Just now we have discussed, no? So how do it will act here? How do it will act? It will act like this. And they will act in such a way that what happens? There won't be slipping. There'll be pure rolling. So when it is striking, climbing up, then everything. So there'll be pure rolling at all the instants. That's what I think the question you meant it to say that one. Okay, now what is the question? We have to find out. We know that's all. If you can get this V problem solved, how to get that V. So what is this distance? R by 4. I'm just shown like almost R by 2. It should be R by 4. To have the clarity of the diagram, I put it here. And tell me like how to bring that V. I'll apply conservation of angular momentum about what? About point P1. Not about P. Why not about P? I think there are 2 points there. P1, P1. Let me take this is P2. About which point I should conserve angle. About P, if I try to conserve about P, what happen? There'll be an impulse due to these two, no? So let me conserve about P1. about P1. What is initial angular momentum? mv naught r minus r by 4. Then angular momentum due to rotation motion about center of mass. Then finally, due to translative motion mvr, then angular momentum due to rotation motion about center of mass. Finish over. So what is the thing? LPZI LP1 equal to LP1 ZF. Initial angular momentum. So this, let me write y. Angular momentum due to translative motion mv naught y clockwise. Due to rotating motion about center of mass clockwise. This should be equal to mvr after clockwise. Then IC omega clockwise. And we know V naught equal to R omega, pure rolling. V equal to R omega, pure rolling. Substitute all this. What is Y should be equal to? What should be the value of Y? R minus R by 4. No need of that theta also. So 3R by 4. Substitute that and solve, you get the required answer. This is a nice problem where some different way of thinking is needed. So therefore, the moment it comes and collides, you must bring what are all the impulses acting and how that will be, and about what point I should consider the angular momentum. Sir, friction will act pure rolling, no? What is the velocity of point P? 0. No friction will act. What is the velocity of point P2? 0. No friction will act. So what are only that impulse act? But sir, mg will act. Due to that, equal and opposite what happen? There will be a torque. Oh, I think the point P, I'll show it here. So therefore, what is the net torque about point P1 is 0. Can you solve? I'll go for next idea. Just only substitution type we have to do it. So now you have to be careful. What is that? When rigid body goes and strikes any step or any inclined plane, you have to be alert. About what point